Well, good morning, everyone. It's Rob and Dan here to give you a 2-hour presentation on Perc-Rite Drip Dispersal. We are anticipating a very large group today, and we got about 60 or 70% of them in. So we'll talk a little bit here in the beginning, give people a chance to log in. Dan, you want to say hello to the group?
Good morning, everyone. Looking forward to catching up with you today.
Very nice, very nice. So let's go through some logistics. So we're going to have about close to 100 people on today. So that poses a little bit of interesting scenario. If you were unmuted, we could get a lot of feedback and a lot of unintentional disturbance. So all of you attendees will be muted throughout the webinar. So the way we're going to handle questions is that in your dashboard, which is in the top right corner of your screen, there'll be a question bar. You type a question. It's completely anonymous. It's only going to go to Dan and I. And then if it's the right time of the presentation to answer it, we will do so, right around that moment. If not, if we don't answer your question right away, it's because there's going to be a portion of the presentation that is more appropriate for that question. So we will get to them. All of your questions will be anonymous. You don't have to worry about us calling you out personally, and we will read them aloud. So I'm sure if you're thinking of a question, probably one of your colleagues is thinking the same thing. So that's how we'll do it. All right. So in today's session, we're going to introduce you to us, Oakson and Rob and Dan. We'll go through the concept of Perc-Rite Drip Dispersal. We will talk about the specific Massachusetts approvals. We will go through design, installation, and sustainability of Perc-Rite. And then we're going to look at some areas that we found over our 15 years being involved in Massachusetts, why some of you have chosen Perc-Rite for a specific site and why that project was successful. And that will lend to everybody thinking along the lines of, how can I use this product and keep it in my toolbox. So we're going to be focusing mostly on applications under Title V. There'll be some references to projects under the groundwater discharge permit guidelines, but the audience today that signed up generally is mostly I think Title V relevant. So we will be hosting another webinar next month focusing on large commercial, industrial, municipal type of systems, and there are quite a few of them in Massachusetts and New England. So before we get started, we're going to take a quick poll or two just to get a sense of our audience. So we're going to ask you to select one of the following. And what's your role in wastewater? So we'll give it about 30 seconds for most of you to respond, and then we'll post the results. All right, we're about 90% done, so we'll take a look. And it looks like about half of you are designers, a third of you are regulators. Then we have some site contractors, some operation maintenance providers, and homeowners or developers. So that's great. We have great material for all of you today. All right, let's look at another one. So what is your experience with Perc-Rite? Is this your first time ever hearing about it? You familiar with the concept, but you'd like to learn more? You've worked on a project in the past, but maybe it just hasn't been built yet, so you're kind of, a little bit experienced. Maybe you've designed, installed, or been a regulator on many applications of Perc-Rite, and maybe you're here for the CEUs, which is totally fine. So let's give you a few moments to check off those boxes. Great. So the overwhelming majority of you are familiar with the concept and willing to learn more. So that's fantastic. So at this point, I think you've seen enough of Dan and I's handsome faces. So I will make us go dark and we'll start with the presentation. So Perc-Rite Drip Dispersal. Oakson is the New England distributor of the product, but the product is a national brand made by American manufacturing company, and they are located in Virginia. So Oakson has been your source for this technology since the dawn of the new millennium. Oakson covers all 6 New England states. So we have, quite a large territory. Our beginnings are in Massachusetts. Most of our experience has been in Massachusetts. So you'll find there's a lot of great content today that we can share with you. This is a map that is a snapshot of it's on our website. So on Oakson.com, on the home page, there's an interactive map. It actually covers all of New England, but I zoomed in here on Massachusetts. So each one of these droplets represents an installed system. The green ones represent, a residential scale system, and the blue ones would be a larger flow or commercial, maybe a subdivision type of concept. Some of the droplets are so close together that there could be 10 or 11 in systems in a small geographical area, which we've seen before. If you click on one of these droplets, it'll bring you to a new screen, and it'll actually give you a satellite image of that site. And then on the left-hand side, it'll provide you background information on that particular project, when it was built, the effluent strength, how many gallons per day, the actual location, and some site pictures and perhaps some videos. This is a great tool if you're a designer and you just kind of want to get a sense of, what Perc-Rite, what type of use it's been in your area, or maybe you have a client who wants to get a better feel for that. This is not a brand new system and it's widely used throughout the state. This is a really good resource for you to share with your colleagues, your clients, or whatnot. So the history of Perc-Rite goes back to really to the 1970s, where effluent disposal was used through irrigation tubing, and it was generally in the Middle East. So they would pipe from the cities the treated effluent out to the deserts and grow crops. In the 1980s, the folks from American manufacturing learned about this and brought the concept back to the States and worked on how that system could work for us, and mostly on-site versions of that concept. They got their patent in the 1990s, and their first system was installed very much early in that decade. And the interesting anecdote is that our first original system is still active, and they actually went back, probably about 10 years ago, and they did a little bit of an archaeological dig and took a look at it, and the parent material, the tubing, everything was fantastic. So you're looking at something that's been in the ground for 30 years and still working exceptionally well. Specifically in Massachusetts, January of 2006, our first approval was issued. And then later that summer, our first system was installed, and and my memory is correct, it was in Weston, Massachusetts. 2015, we received our last approval, and that was in Connecticut. So as of 6 years ago, we are approved in all 6 New England states. So here is a little bit of the background of how Perc-Rite came to New England. Is really all about Dan. You know, Dan worked as an engineer at Mass DEP for a while, and then went to the city of Gloucester, and they were having a lot of on-site issues for pollutants along the coastline, and he pioneered a lot of different technologies coming into the region. He learned of Perc-Rite and basically went to the private sector and brought Perc-Rite to Massachusetts and then throughout New England. So let's go right into the nuts and bolts here. So Perc-Rite is equivalent to pressure distribution under Title V. So that's a very important thing just to get over with right away. We are considered pressure distribution. We are also approved to discharge both primary or treated effluent for new construction or upgrades repairs. So we have a general use approval, we have a remedial use approval, and both approvals allow primary or secondary treated effluent disposal. So here's a little flow chart of how the system works. We will have effluent generated into either a septic or treatment tank. It'll carry over to a pump chamber, pump through a device called the hydraulic unit. From the hydraulic unit, there'll be a force main that'll take the effluent to a manifold, which feeds the drip dispersal tubing. The drip dispersal tubing does not have to be in a perfect rectangular shape or perfectly spaced. You can see here in the rendering, it goes around a tree. It cuts short of another tree. It goes through all the tubing, and it basically goes into a return manifold, back to a return force main into the hydraulic unit again, and then it has the ability to discharge back into the septic or treatment tank. That gravity discharge line back to the primary tank will allow us to not only clean the tubing when it's needed, but also clean the filters that clean the effluent before it goes out to the drip field. And we'll go over that in a little more detail throughout the presentation. So here's a rendering of, your own backyard. A lot of people walking around your backyard. It's kind of interesting there. But this just gives you a little idea of how this could fit in a residential application. So what we call a single piece of drip dispersal tubing is a run. A collection of runs make a lateral. So this would be fed through a manifold. So one lateral is a series of runs put together. Many series of runs or laterals tied together we'll call a single drip dispersal zone. Typically, residential applications will only have one zone. We'll have our septic tank or treatment tank, carry through to a pump chamber, pump through the hydraulic unit. We'll have the supply and return force mains and manifolds and that gravity return line that goes back to the primary tank. There's a control panel that controls the whole operation. There's an air release valve that allows instant pressurization and also the ability to purge the lines after the pumping. And that is a Perc-Rite drip dispersal system. Class dismissed. So when you look at the tubing in operation, this is a great example of just prior to backfill when we do our system startup. there is a wetting front. So this represents each of the emitters in the tubing showing the discharge. And what's pretty unique here is that it's quite uniform. And when we look at it a little more closely, it's extremely uniform. It's very precise, as a matter of fact. Each one of the emitters is putting out at the exact same application rate, which is 0.61 gallons per hour, okay? So it's a very, very small amount coming out of each emitter. And this works over a range of pressure. So if the tubing has pressure at about 7 pounds, all the way up to about 70 pounds, you're going to get that exact same application rate. And what's critical for this is that the system does not need to be installed on a flat bed. This can be on a sloping site. It could also have irregular shapes. So perhaps you have a situation where you have tubing that is closer to the pump, lower elevation than far away from the pump. You're going to get the same exact application rate. The tubing it goes under up to 70 pounds of pressure. So inside the pipe, there's a lot of pressure, but once it reaches the outside, it gets back to atmospheric pressure and just turns into a drop. So you can see here the tubing is upside down, and once it gets to the surface, it just dribbles off. If this were upside down and you put your hand under it, it would be like a droplet of water. So it's just like a leaky faucet. So in order to achieve that pressure inside the tubing, there is a manifold configuration. So when there is no slope to a particular drip dispersal zone, it'll be what we call a side feed manifold. And that's very similar to your pressure distribution type configuration, where you have force main below the frost zone, and then it goes up to the pipe. So you can see here the different laterals that are ready to be connected to the drip dispersal tubing. So again, it's a side feed manifold, no slope. For a sloping site, and this site has quite a bit of slope, we call this a top feed manifold. So the force mains go to the top of the field. You can kind of see, the pipe sticking up out of the ground there at the very top of the picture, and then it feeds down the slope into the drip dispersal tubing. Now, the pressure at the very top of the slope could be 20 pounds, and at the bottom it could be 50 pounds, but you're going to get the exact same application rate all the way through the drip dispersal zone. So this will be probably the only time I'm going to say we have any questions. So at any time you can ask a question throughout the presentation, just type it in there and we will get to it. So I just wanted to remind everyone that questions are taken through the typing portal. Okay, good. Let's talk about the approvals. So Mass DEP issued our first approval in 2006. We have both a general and remedial use approval. And we are fully approved under Title V for new construction or upgrades, septic tank effluent or treated effluent, secondary or better. So pretty much any type of system that you need to build under Title V, Perc-Rite can be an option for you. Some of the key aspects of our approval through general use and or remedial use. We are considered pre-engineered under 2,000 gallons per day. We are equivalent to pressure distribution. There is no 5-foot overdig required, and this is not a variance or anything. This is written right into our approval, so you don't need to ask for any relief. It's granted. There is no need for an inspection port. There are no vents required. We can be as close as 5 feet to a cellar wall. The tubing can be installed in the parent material A, B, or C soils. the tubing can be as shallow as 6 inches below finished grade. So that comes into a huge play when we're dealing with mounded systems. Perc-Rite will end up being the shallowest type of option that you can choose. And there are some flexible reserve area requirements that are given to us under the approval. There are some instances where we have to issue some letters for any system greater than 2,000 gallons per day. Oakson will provide you a letter of review so that you will turn in with your submittal. Perc-Rite can be installed in Class 4 soils. If you choose to design in a Class 4 soil, you will need an accompanying letter by Oakson again. And for any type of non-residential systems, commercial, restaurant use or whatnot, we will also issue a letter of review of your plans. So sizing, really simple. We are the same size as any Title V leach field. So if you're just doing a traditional, Class 1 type of soil, you can use the same loading rate under Title V. Because we are equivalent as pressure distribution, we can use the pressure distribution loading rate chart. And that goes for same thing for any type of local upgrade approvals. We are certainly, you certainly can choose to do that with our technology. And if you're using a treatment system, you can gain the relief that the treatment system approval gives you and use with Perc-Rite. We have a good question here that I'd like to ask. So the question is, why is it acceptable to install this system in the A soil horizon? Dan, we haven't heard from you in a while. Would you like to chime in on that one?
I would. Can you hear me?
Yes.
Oh, great. So we want to get as much natural treatment as we possibly can, and the A soil horizon contains the most organic material and the most microbial activity, and allows for the best treatment of the effluent when it's applied into the soil. So that's a primary factor. Also, just simple matter of construction. If you're building it in the woods or in someone's yard, we're trying to minimize site disturbance. So pulling it right into the A soil horizon is a great way to reduce the impact on the land during construction.
And another good reason why we would go in the A soil horizon, or at least be permitted to do so, is because of the small micro doses and the very precise application rate. There is really no concern for ponding or pooling in those upper soils, because it's spread out so uniformly and it's such a low application rate. There is no reason to believe that there'd be any problems, and that's been documented over our 15 plus years in Massachusetts. Another quick question was, what is the deepest you can put a system? Our approval states that it can be between 6 inches and 24 inches of burial depth. And it would work very well deeper than 24 inches, but the reason for that is that we want to be in the oxygen-rich soil layers. Science shows that anything deeper than 24 inches, you're not really getting great oxygen transfer through the soil. So we're limited between 6 and 24 inches. There are a lot of other good questions that I'm gonna push ahead, because we'll be covering these topics in some future slides. So keep them coming, guys, but we very much appreciate the interaction. So we are included in the guidance manual for groundwater discharge projects. So if you are a designer working in that area, there is great information there, and Perc-Rite is a very viable option. the rendering that we show a lot on the right is actually a real project. So I wanted to take a satellite image and share it with you so you can see how the grass is quite thicker over the dispersal area, because this picture was taken in late November. So most of the other grass on the site is dormant, but the warm effluent being with the uptake into the grass roots is keeping it quite more alive throughout the season. So our approach, Oakson provides full support from the design concept, installation, all the way through operation. So let's talk about some of those specifics. Let's go through a residential design. So if you are a designer, you could go and grab the design manual that we have on our website. It's also included here as a handout in your dashboard if you'd like to download it. Or in today's world, we've seen a lot more use of video and YouTube videos for demonstration. We have a great video on our website that Dan hosted that walks you through an entire Perc-Rite Drip Dispersal design. So we encourage you to do that as well. And along that on our website, all the resources you will need to be successful with a Perc-Rite design. So all of the approvals, installation guides, the AutoCAD details that you'll need to pull together your plan, and more video tutorials on how to do it. Now, we're trying to keep this presentation to around 2 hours. It would be impossible to give you an overview of Perc-Rite and all the different nuances it brings and have a very, very in-depth design portion of it. So we'll touch upon it. And if you want to get into more detail, all those resources are available, or you can also just reach out to Dan or I. So if you're a designer and you're kind of pondering whether or not Perc-Rite might work for your site, you could send us like a simple sketch and we'll help you, think it through so we can get something, pretty crude like this. Or sometimes it'll be a little bit more details and just say, hey, look, I got a lot of trees we're trying to work around. There's a walkway. I have a very limited area. What do you think, we can do here? Or more specifically, this is really the ideal situation for us to help you. And we would ask that you would send us your design criteria. So what your design flow is and what your soils are, so we know what the sizing needs to be. And then perhaps give us a site plan that shows approximate location of your tanks, and then maybe a hatched out area that would be available for disposal. And then we can look at it and give you a very defined Perc-Rite layout that would not only meet all of the requirements for your site, but also be laid out in such a way for the most efficient method of installation and future operation and maintenance visits. So when we interact with you, we're keeping in mind, sure, we can squeeze it on a plan, but in reality, how's it going to work in the field, and how is an installer going to be able to build this efficiently? So when you provide us the information in this context, it'll allow us really to draw on our experience and give you a design that will work well from design all the way through installation. So let's look at a real true specific design. So a designer sent us a plan, and you can see it's a 3-bedroom. The soils aren't great. They decided to use a treatment system, and the nature of the site was they had to work around a lot of different obstacles. The house, some wetlands, some unsuitable test pits. So they ended up with a serpentine-shaped field, which is fine. If you were to take the equivalent area of that field, it would meet the area required under the Title V design calculation requirements. So the designer, gave us that shape. We worked with them to put the tubing in there and build the manifold. And we have a very successful project due to that. So it's this particular project is in Aquina on Martha's Vineyard. We have a very detailed video on this project that is on our website if you care to learn more about that. As part of our AutoCAD details, we provide what we'll call, the page 2 or note section and schematic part of the details, where we'll give you notes that to help the contractor during construction, demonstrate the manifold on how it will lay out, show you what the equipment will look like, have a system profile, all the things that will assist the contractor in understanding what it's going to take to build the Perc-Rite system. So all these are available to you on our website. So a large flow design, it's very similar, except that we're going off of the groundwater discharge guidance document. There are groundwater mounding calculations that need to be taking place, much larger zones, and the equipment is not, the details are not cookie cutter. So we don't display the large flow details on our website because they are quite unique. So you can see these manifolds and zone layouts are not something that you'll be able to pull off of the chart on our website. But nonetheless, we are providing very customized details, and also, most importantly, all of the math for the friction loss calculations to determine what pump size we came up with, what size force mains will be used to achieve that pressure inside the drip tubing. We could have a zone that's a half a mile away. We could have a zone that is 100 feet of elevation change, quite common for these large projects. But Oakson will provide you all of the calculations that are required for our design, and then you can go through and make sure you're happy with those. So that is what we're going to focus on for design at the moment. And there are a couple other questions that came up, and that might be a good time to answer. So one of the questions was, can this be installed under a parking lot? Great question. So our approval states that it cannot be installed typically under a parking lot. And the reason being is that it will work, it will drip, it'll function, but because a parking lot will choke off that oxygen transfer, there is a potential problem, potential for maybe long-term soil clogging because of that. We have done some pilot testing with venting the drip tubing under parking that has been quite successful. So currently we did not petition for a change to our approval because we still want to say that it is not approved under parking. But if you have specific areas that you'd like to entertain it under parking, we've had some success with that, and it would just need to be a variance. So great question. Another question is, what different types of installation methods are, that we prefer or whatnot. I'm going to push that forward because we're going to get into all different great types of installation. And then another question was about tree roots near a field. Do they wrap around the tubing? Any potential plugging or whatnot? Great question. So because of this tubing was really designed for the irrigation world, it interacts with roots extremely well. So the root system for vegetation or trees will be attracted to where the emitters are and potentially want to wrap itself around the tubing, but not like a boa constrictor would wrap around its prey. It would like to be in the presence of the emitter and actually provide great uptake at that point. So you'll see that tree roots or vegetation will interact with the emitters. because the emitter is operating under pressure, if a root or a baby root tries to grow into the orifice, the next time the pump comes on, it'll spit it out, and then it'll just continue to wrap around. So we haven't seen any problems with root infiltration into our tubing, as we've all seen in more traditional gravity type systems. There are some other questions about the freezing question. Okay, so if, oops, sorry about that. So for freezing, yes, the tubing is installed at only 6 inches below finished grade. Even at 24 inches in New England, that would be considered the frost zone. So how do we get by with this working? And the answer is really simple. The tubing is designed to drain at the end of every pump cycle. So on that operational curve, you notice at 7 pounds, it'll achieve its operating pressure and drip at that rate. Anything below 7 pounds, the tubing will drain into the soil out of the emitters. So when the pump shuts off, it'll continue to drip for a few seconds. The pressure drops below 7 pounds and everything drains into the soil. The tubing is laid level along the contour, even on sloping sites, so that the draining of the tubing occurs at each orifice along the line, so it'll drain equally over the length of a piece of tubing. So sure, we are in the frost zone, but every time the pump comes on, we're pumping warm effluent at pressure out an orifice. It gets into the soil structure, migrates through the soil, pump shuts off, everything drains, no problem for February operation. Great question. So for regulators, what is our role in working with regulators? So if you're a new regulator and for a particular town, and you have a plan for Perc-Rite and you don't have a lot of experience with it, please give us a call. We'll walk you through the technology, we'll walk you through the approval, we'll assist you with any questions you might have. Potentially, there are projects that require meetings, and we've often attended meetings, and there are some of our regulators out there in the audience today that have, can bear witness to that we will go and we'll speak to your board and answer any questions you might have about our technology. I think most importantly, for every installation, we're going to issue a letter of certification stating that Oakson was involved, or one of our representatives, at a particular project, and here is a letter stating that the system has been built according to the DEP approval and the approved plan, and it is operating the way that it should. And then I think lastly, what I'd like to say is that, we have systems in the ground here in Massachusetts for over 15 years. There are a lot of turnovers for homeowners, a lot of turnovers for health agents in particular towns. We maintain what we call, we're like consultants for life to all of the Perc-Rite systems that are installed. So we may not be involved in the day-to-day or say yearly operation of the system, but we will maintain contact with all of our partners that are involved with this. So you as a health agent, you as an operation and maintenance person, if you're new to this project and you have a question, or if something just doesn't maybe seem right to you, we will be involved with the life of the system. So let's go into some installation examples. So what is Oakson's role in the installation? So I think it's important that we're going to define some roles here. So we are involved before the installation, working with the contractor to go over planning. So we're going to walk them through the actual project prior to construction, talk about some key points, help them compile the proper list of parts so that the day of installation we're not all running around. We will provide electrical schematics for the system. So if the electrician needs to have some questions, we will help them answer all those prior to the day of installation. We have a library of video demonstrations. So if you're a contractor who really wants to learn about something prior to, we have all of the information you will need to be an expert prior to the day of installation. We provide, as a company, a technician for all of our installations. So whether it be an Oakson employee directly or a third-party trained individual that we hire to help the contractor. But for every project, there will be an extension of Oakson there to assist the contractor. Now, we are not your primary source of labor, okay? So we are not going to be, there and you guys, take off and expect us to hop in your excavator and trench or whatnot. But we are going to work side by side to make sure that you're doing the job that you do well, and we're leading the charge through our experience with the technology. Our goal is to remove all the guesswork for the contractor. So through pre-construction planning, the tutorials we have online, and then the interaction through the day of installation, we found that all residential systems should and usually are built in less than 1 day. So it's a very efficient process. Sorry, I'm talking a lot, but I think it's important that we define, these roles. So as a contractor, what are your expectations, right? What are we expecting you to do? You are going to supply and install all the tanks like you would at any other type of septic installation. You're going to prepare the drip dispersal area. It could be a sand bed that you're preparing like you would for another type of system, or if it's going to be a plowed in installation, which we'll talk about shortly, you might be marking out your extents or marking out your contours with your laser level and flagging them out. So a little bit of preparation there. You'll be providing the rigid pipe for the force mains. So Oakson provides a comprehensive package of all the materials for the system, but we're not in the business of reselling common pipe that you can just get at your local supply house. So you'll be supplying, that force main. You'll work alongside us, during the installation. And your job is going to be, you're going to secure the electrician. Sometimes if you're working as a sub to a general contractor, perhaps the general contractor will be supplying the electrician, but it'll be your role to sort of be the intermediary to make sure that an electrician is lined up to do the wiring. And then finally, it'll be your job to do the backfill and the compliance documents. So the certificate of compliance, you'll need to do your end on that. And then also sometimes that we will ask you to help us interact with the homeowner to make sure that the operation and maintenance the document is signed prior to the installation. So we may not even have contact information for some of the homeowners, but since you're hired by them, we'll ask you to help us, get that the O&M contract executed. So let's go through some drip dispersal tubing installation. But before we do that, let me just peruse some of the questions. Great follow-up question. Let me tackle this now. If the ground is frozen, how does the water drain through the soil? Excellent question. They're all excellent questions, by the way. So if you were to look at frozen soil under a microscope, the molecular structure is actually wider and more porous than unfrozen soil. So when you're forcing a drop of water at about 48 degrees at pressure into frozen soil, that soil structure will receive it and thaw it out just around the emitter. Okay, so essentially, the field itself, the drip dispersal field, will be unfrozen because of the activity that constantly goes on. So that's why you'll notice, especially the grass continues to grow much later in the season, and even throughout the winter in some of the more milder climates like Cape Cod. So that's how that works. Another follow-up question about frozen soils is that what happens if, if a house is left vacant for quite a while and it's not used often? And the answer is generally the same. If we have many systems installed in the Berkshires along the ski resorts, or even in Vermont for that matter, where they're only used on the weekends, because the soil is frozen doesn't mean that the warm wastewater can't migrate through that molecular structure. So, great answers. Another question was, what happens if the house is abandoned for a few years and the roots grew inside the tubes? That won't happen because the tubes are empty, so there's not going to be any water there, and there's not going to really be a need for the tubing, for the roots to grow inside the tubing. We have close to 1,000 systems installed, and in all honesty, we've never had a question where we've had, clogged tubing because of roots. So I'm going to go on faith to say that hasn't been the case, and I think with 1,000 systems under our belt, that's the case. So moving on, drip dispersal installation in a sand bed. A little bit to talk about here, but not too much. Here is a great example of a sloping sand bed that's irregular shape. So we notice that we'll have the contractor stake out the field with all jogs, and then we're going to go in and we're going to paint some lines along the contour. So that allows us to go back and just pull the tubing and cut it and stake it in place and have the proper spacing. So for a sand bed installation, it's quite simple. If this were a more regular shaped bed, we may just choose to say, let's cut 12 lines at 50 feet long off to the side and drag them into the sand bed and stake them down. But for a sand bed installation, it's quite straightforward, like you see here. Some more interesting examples of drip tubing installation. It can be plowed into existing soil conditions. One of the first things we talked about was the ability to use the A and B soils. That applies here for existing lawns, okay? So obviously we need to have, proper groundwater separation, right? And so that's achieved here. You'll notice that on the picture on the left, where we have somebody painting some lines, it's giving the irrigation person the ability to have a path to follow. This particular lawn has some slope, so we're painting the lines following the contour. So the contractor will go along with his laser level and sort of put a dot in along the same elevation along the line, and then we'll go back and connect the dots with the paint gun, and then allow the irrigation person to go back and pull each run into the existing surface. Now, the vibratory plow has a skid plate or a marking on there that allows the operator to drop it at the proper depth of installation. So the first run that goes in will move along about 10 feet or so, then hand dig it out and make sure we're at the depth that we need, and then set the blade at the proper depth so that as we drive along the contours, we're getting the proper depth along the way. So lawn installations are a great way to not only preserve the site conditions, but also save time and money because there's no need to import expensive fill material and have to strip out perfect loam and grass. So quite a very unique but efficient way of installing a disposal system. Sometimes, and this is more applicable for large scale installations where we're plowing the tubing into a sand bed, and you might ask, why would you do that? Why would you just plow it into sand? Why wouldn't you just lay it on the surface? And the answer is really backfill. If you think about the reach of a machine, you only can kind of reach out so far with the extension of the boom and the bucket. So when we're dealing with large flow projects, we have typically beds that are 150 or more feet long and could be 300 feet wide. So if you think about drip tubing staked down on such a large area, it would be very difficult to actually trek over the tubing. So, probably about 6 or 7 years ago, we came up with a concept that has worked quite well. So the engineer would specify what the tubing elevation would be. Let's call it elevation 100. So that's where your sand bed would be for the tubing. But then the contractor would install an extra 6 inches of that same select sand, Title V or C33 sand on top. So now we have an envelope of sand that the machine can drive over and install at a depth of 6 inches. When the tubing is at a depth of 6 inches below sand, it allows the contractor to drive over the field with a track machine, right? A low load track machine. It's not causing any sand compaction problems because the sand is already well compacted, and it allows the most efficient way to both install and backfill a very large drip dispersal area. Going to cut in with a quick question. Can the system double as a sprinkler system, or does striping occur? So the answer to that question is no. We are not considered irrigation, just because irrigation is typically you think about it as spray irrigation. So we're at a depth below finished grade that would protect us from pollutants reaching the surface. Is there striping? So what we advise our clients is that you can treat the grass area above your drip dispersal system the same as your surrounding lawn. So you want to make sure that your surrounding lawn is properly irrigated and fed with fertilizer, because your drip dispersal area is going to be receiving water and nutrients. So it could look more plush if it wasn't treated the same throughout. So striping is more a result of when the rest of your grass goes dormant, but during the healthy growing season, if you're treating your yard the same, you'll find that everything looks quite nice. So let's talk about some trenching installation options. So sometimes the vibratory plow is not the best choice, and that could be a wooded installation or an area where there are a lot of tree roots or whatnot. So you can use an actual a chain trencher to build to make a little trench, and you can put the tubing in that trench and then rake the material back over. So this occurs sometimes where there are roots or more difficult soil, and it is as one extra step, but it's quite a good solution because you're not needing to import more material. So trenchers can be either a hand machine like you see on the left, or there are instances where the chain trencher can be installed on the front of a skid steer machine and navigate through more difficult slopes or terrain that would require a machine. Another good question I wanted to throw in here: can an irrigation system go on top of a Perc-Rite system? So the answer is yes or no. What we've seen is the best way to do it is that you can run perimeter heads around the system and throw onto your grass, but we don't want to ever install an irrigation system over a Perc-Rite system, and that's mostly because of damage. I would be lying if I didn't say we've gotten a call from customers who built a brand new house, had a Perc-Rite system, but unfortunately the last people to go through are the landscape contractors and irrigation people, and they've plowed lines right through the middle of a brand new system. And that was done inadvertently. We try our best to say maintain your yellow caution tape around the field, but sometimes that happens. So we do not like to see irrigation pipe over our system, but it is not against the rules to throw the water from a perimeter basis. So this would be the most extreme example of a trenched installation. We had a client who loved their wooded site to the point where there was no sapling, nor rock, nor semi-mature to mature tree that could be disturbed. As you can imagine, they had deep pockets, and they decided to have the contractor hand dig trenches throughout their entire dispersal area. What was very unique about this installation was that you can see in the pictures that all the leaf litter was blown off of the area that the drip dispersal tubing was to be installed. So this was a mid to late fall installation. So the contractor blew all the leaves to the side. They did their hand trenching. They installed the tubing, raked it back over, made their manifold connections, tested the system, and then blew the leaves right back on. So basically, if we were to take you to the site and bring you into the area and say, tell us where the disposal field is on this site, you would never know. It's just so beautiful and unique. We do have quite a few examples of these types of installations throughout Massachusetts, where trees and preservation of site features is very important to our customers, and there are very qualified ways of doing this type of installation. So of course, this from a cost perspective could be a little bit more for the actual labor, right, to put in, and that's a question that just came up, so I'm kind of segueing into that. But from the cost of the equipment, it is quite the same. So the question's already been posed on my board here. What does the system cost? A residential system in Massachusetts, and for that matter throughout New England, cost about $9,000, and that includes the pump for the system, the floats, the hydraulic unit, the control panel, all the drip dispersal tubing you'll need, the manifold fittings, any air valves or other appurtenances, check valves that are needed to build the manifolds, and that installation support that we talked about earlier. So that is about $9,000 for Oakson's components. The actual cost of the installation, for this type of extreme example, could be a little bit more than stripping the forest. But again, it's up to your client to decide to what level of preservation suits their needs. And in this case, we have this as an option, for them. A great question. How do you determine a loading rate for the wooded site and for a forest wooded site? Great question. So under Title V, and I didn't really get to this into much detail at all, to size a system, we go by area. Okay, so you'll, just like any other disposal system. So say you need 1,000 square feet of area. For 1,000 square feet, there can be no less than 500 linear feet of drip dispersal tubing. The reason for that is we get credit for 2 square feet for every linear foot of drip dispersal tubing. So essentially, if you have a piece of tubing, 1 foot on either side of it is credited for effective leaching area. So on a wooded site, you would do your calculations, right? And say we need 1,000 square feet. We have to successfully install a minimum of 500 linear feet. It's probably going to be a heck of a lot bigger than 1,000 square feet, right? Because you can see the distance between the trenches, but that's okay. If the property can support a leaching area with all the setbacks to wells or wetlands or property lines, say you have available to you more than that bare minimum, then we can spread it out over a greater area. Because what does it matter? We're not importing fill, we're not excavating, we're doing mini trenches. So the way you would attack a design is you would look at it from how much tubing do I need on a linear foot basis and apply it to the site based on the available area you have that meets your setbacks. Excellent question. From a former regulator, very good question. So manifolds, Oakson will assist with the manifold installation. So sometimes the manifolds are buried, 4 feet below grade for your side feed manifold. And you'll feed up through the frost zone. You can see the picture on the right that we have very adequate insulation on the piece of force main that's going to be interfacing with the frost zone. The picture on the left shows how the tubing will connect to the force main pipe. And as a contractor, need not worry. This is one of the aspects of Oakson support that will make sure that we walk you through and assist all the way through the time of startup. So this is not something we're expecting you to understand at your first, installation, or if you're second or third for that matter. We will provide the necessary installation support, whether it's your first installation or your 20th. And I think where our most experienced installer in Massachusetts has installed 37 Perc-Rite Drip Dispersal systems at the conclusion of 2020. So there are, and there are quite a few installers out there who are well over 10. But we'll provide as much support as needed to our installer colleagues to make sure that they feel comfortable and that we're spending your time most efficiently. Question on the trenches. Typically, the spacing on tubing can be no closer than 1 foot. It can be closer if we're kind of working around an obstacle. So say we're working around a tree and we get a little bit closer just for a couple of feet to a nearby trench, that's okay. But we want to keep our spacing regularly as close as 1 foot. And again, no further than 2 feet to count for effective leaching area, but it can be wider if we're avoiding obstacles and we have more area available to us. Okay, Now, at this point, we're going to not take a break and run away from your monitor, but I'm going to show a couple of videos. And it's important at this point because video is such a huge resource for all of us to learn. And we were forced to do so through the COVID pandemic, is to kind of grow our resources to help teach. So Oakson has invested a lot in video over the last year and a half to still interact with those who need the teaching tools to learn about this technology. So the first video is going to be vibratory plows pulling tubing into different types of terrain. There is no sound for that video, so I will be your narrator. I will be Morgan Freeman, for that matter. The second video, we're only going to show you the first couple minutes of it. It is one of the complete installations that we show on our website. So we want to introduce you to that to show you how in-depth these videos can be. This video is about 15 minutes long, and we don't expect everybody to have the time to invest 15 minutes in that. We're certainly not going to do that during this presentation. But a minute or two of it would be a great introduction so that if you do have time to invest later on, you can do that at your convenience. That video has an audio component to it, so I will be muted and you won't hear from me. But once I shut it down, we'll get back to the presentation. So here we go. So this particular, this is an example that you saw in some of the pictures. We're seeing the ditch witch going through the grass, and it's reaching the end of the line. And this is where they're going to pull up, cut the piece of tubing off and transition. Now you can see the little burrow left by the machine, and that easily goes down with a hand tamp or just driving back over it with the tire. Here is a different type of ditch witch pulling through. The video is going to speed up, so now we're going at like 4 times speed just so we're not here all day. And you can faintly see a string line attached to a stake at the end of the sand trench. That's so that the operator can drive the machine in a straight path to ensure that the spacing for the tubing is maintained. Those blocks affixed to the machine are keeping the tubing at the proper depth for every pull. So you can see the earlier remnants of those lines. This video is taken by the newest addition to the Oakson team, which is the Oakson drone. So we're flying over the field. This is a Title V system that's 7,000 gallons per day. It was installed in late December. And the field is about 120 feet long. So each run of tubing takes between 3 and 4 minutes to pull in. This is running at about 4 times speed, just so we can get through watching a little portion of it. So the driver finished his pull. Now he's driving back to the area where the tubing is on a spindle. They'll reattach, drop it to the depth, and then continue on. So we pulled in enough dispersal tubing for about 7,000 gallons per day in a little over 5 hours. The only assistance you really need is to make it go as quickly as possible is somebody at each end that moves the stake and the string line while the operator is driving back. So it's really, you don't need a lot of skilled labor. Actually, this irrigation contractor can be hired as a sub of Oakson to pull the tubing in for you. So we're getting near the end here, so we're slowed back down. And you can, so we actually witnessed a couple of pulls here in this limited video. So now I'm gonna take you to the video with the audio portion of it. So stand by. All right, so I am back. Hopefully everybody got to see that. This whole webinar technology for us, it's, this is only the second time I've done this for the large audience, so hopefully that video came through nicely for you. But that runs about another 10, 11 minutes and actually takes you through the entire process of laying the tubing, connecting the manifolds, building the manifolds, setting the pump, the floats in the actual startup. So it's quite informative. If you have some time in the future, please take a look. Okay, so the next thing we're going to talk about is sustainability. I like to use the term sustainability rather than just call it O&M, because we feel as though that the product has a great track record of working for a long time, not only in Massachusetts, but we've learned about this through our American manufacturing with the systems way back in 1990. So again, active systems for over 30 years. We have a very durable types of components. So our systems, the pump is a very high quality, high head pump. The hydraulic unit is built with great components, the control panel as well. All of the actual mechanical aspects of it are superb. One thing though, that what makes Perc-Rite very sustainable is that time dosing aspect. The tubing isn't demand dosed. So there's a timer that goes off. We'll talk about that a little bit more shortly, where the system will run for 10 minutes, rest for a few hours, run again for 10 minutes. For larger systems, when there are multiple zones, it'll start with the first zone and then go to the second zone and move on from there. So the activity of the resting of the soil promotes that oxygen transfer and allows the soil to be to not clog over time, as traditional disposal systems are designed to do. So Perc-Rite is not designed to grow biomat and work its kind of its way out of the laterals. It's intended to remain active and porous for, you know, well, I can say at least 30 years, but you know, the clock is still running. What allows us to maintain that tubing is that it is routinely flushed. When we went through the flow profile of the system, we talked about that return line. So not only are we pumping out to the system, but we're also creating a mechanism for the tubing to clean itself with the effluent. So there's a valve on the hydraulic unit that's typically closed that will open up about once a week and flush the tubing at scouring velocity. You can imagine septic tank effluent and a 1/2-inch diameter pipe could promote slime growth. Of course it could, but in this case, we're dealing with it mechanically and flushing the tubing. There are other different drip dispersal tubing options out there, different than the Netafim product that we provide, that uses a herbicide to deal with slime growth. You know, Perc-Rite has chosen to use a more mechanical way to do that because that herbicide can wear off over time and lose its effectiveness. So we're dealing with a mechanical aspect all along. And then the last thing I want to talk about is repairs. And Dan, you want to talk about in the early days of Oakson when you're worried about, you know, everybody you know playing bocce or the bird feeders, and the first time we ever heard of a repair?
Yeah, that was my biggest concern as a former regulator, was causing an urgent public health problem in someone's backyard. But the truth is we've had maybe 2 calls about it. And the first one was 12 years ago. It was a fence company down on Cape Cod, and they sheepishly called us up and said, we accidentally used a post hole digger and dug through a line of drip tubing, and we just overnighted them the repair coupling, and it was fixed the next day. So very simple resolution.
And that's the truth. You know, it's you know, we understand, you know, accidents happen, and it's a very simple repair to deal with the actual field components, because they're only what 6-12 inches typically below grade. So you don't need an excavator to deal with any of those, you know, concerns. So let's talk about the actual operation and maintenance requirements. For residential systems, systems under 2,000 gallons per day for that matter, residential sized, there is the requirement for an annual preventative maintenance visit. So once per year is all that the Perc-Rite system requires under the DEP approvals. For systems that are over 2,000 gallons per day, or for non-residential systems, so you know, restaurant, a commercial building, then we get bumped up to quarterly visits. There are no testing requirements for Perc-Rite. If Perc-Rite is part of a wastewater system that has a treatment unit that does require the testing, then that particular technology will, you know, trump us, and then their aspect will get tested. But it's not like any Perc-Rite testing is required. When you're dealing with systems under the groundwater discharge permit regulations, there are specialized maintenance programs in place. So we will actually write an O&M manual for the project that will detail the frequency and whatnot needed for that particular system. Many times these large projects are phased in, and you don't need to have, you know, weekly or visits early on. So we want to build it out so that it is proper, both for the association to not have to pay for services not needed, but also, you know, when you think of the maintenance world, it is quite hard to find qualified maintenance people. And I know all the companies are hiring, and I'm getting a lot of amens here on my chat from the maintenance people out there that, you know, it's an industry that is dire need of younger qualified people. So if you know anybody that is in trade school or whatnot, or looking to get into career, wastewater maintenance, you can get 10 jobs, you know, right now. And just parlaying that point, Oakson doesn't do the maintenance. We are a company that works up front with the designers, installers, and maintenance providers, but we have decided to partner with highly trained professionals in the business to handle all the maintenance. So we have like a sort of an arm's length view at that. So we're trusting the professionals out there to do the job. We're giving them all the tools and resources they need to do their job well, but they still report back to us. So we are still very much involved with all the reports and save them and help them on an as needed basis. So that's how Oakson is involved with operation and maintenance. So, we've talked about some of the components. Let me just formally introduce you to them a little bit. So we supply a pump. It's a high head effluent pump that works very well over a wide array of lift and distance. So a very small pump does a very big job for us. So it's typically half horsepower on 99% of the residential projects. Along with the pump, we provide a pump mounting mechanism called a cool guide, which allows for protection against any solid carryover that could happen in a system that it may have fallen through the maintenance cracks. We provide sump of up to 16 inches, and there's also a built-in way for water to be drawn over the motor of the pump to cool it during operation to have it last 10 plus years. So here's some examples of the hydraulic unit. So this is the mechanism that the pump pumps through before it goes out to the field. So you'll notice some filters that provide final filtration before it goes out to the tubing. There's also some valves that allow the effluent to be directed where it needs to go. And most importantly, a flow meter, which is an unbelievable diagnostic tool for many reasons. One is that the drip tubing has a very precise application rate, so we know for 400 linear feet of drip dispersal tubing, we should be getting 2 gallons per minute. So we build a drip system with 400 linear feet, we start it up. All we got to do is look at the flow meter and time it for a minute, and we know that we're running properly. So even for systems that are trenched or plowed in below finished grade, and you're not seeing the beauty of that wetting front, we can time it on the flow meter and precisely verify that it's operating at its designed flow rate. The picture on the right is a commercial sized hydraulic unit that is inside a treatment building. And in that case, they chose to use suction lift or centrifugal pumps, which is an option for larger systems. So we can do submersible or suction lift pumps, whatever you decide for your design. And of course, we're supplying all the drip dispersal tubing your project should desire. The control panel is typically mounted on the outside of the home, or sometimes on a pedestal near the components if there's quite a distance. There is a red beacon light and a buzzer as required under the code, and a silence button on the side that the homeowner can silence. We don't ever recommend that they open the unit. The panel on the right is a very sophisticated touchscreen panel with SCADA and motor and VHDs and all the things you need for a big treatment plant groundwater discharge operation. So it can be a very simple panel for our residential, all the way custom built up for your 100,000 gallon plus per day systems. All right, so earlier in the presentation, I talked about there are many instances where designers have chosen to use Perc-Rite because they didn't have quite other options using a site. So I want to share some of those reasons with you on how a Perc-Rite project could be implemented into a potential design for you. So working with slopes. So when you're dealing with slopes, we don't have to build a flat site, right? So we can follow the natural contour. It essentially allows you to stay as low profile as possible. And if you've ever designed pressure distribution for a sloping system, it's a nightmare. But with Perc-Rite, because we can work on that range of pressure between 7 and 70 pounds, you don't have to worry about designing different orifice sizes or spacing, or having a ball valve on this lateral and cranking it closed on that lateral. So basically the tubing accounts for all of the engineering you need to work with a slope. And you can see here a great cross section on how the tubing just goes above the existing grade for a raised system and minimizes the amount of fill needed for this particular site. So low profile, how 6 inches of cover material can help you with projects, both new and repair. This is a repair on Cape Cod, and the existing patio was next to a failed system. So because of the nature of the site, any other system would have been above the patio, and the folks would have had to walk up, a 2-foot mound in their backyard, which overlooked the ocean. So it wasn't something that the homeowner would have been happy with. So a Perc-Rite system was built in place of the failed system here, and the finished grade is going to be precisely the same as what the lawn was below the failed system. This is a new construction where that you can imagine if any other system here would have been a couple of feet in the front lawn, so you would have walked out your front door and you would have saw a big mound in your beautiful new construction system. Or this example where we're only 5 feet to the cellar wall as allowed through our approval, but you'd walk out your front door and your front door might even hit the mound, it's that close. So we were able to tuck this in very close to the foundation and have it be low profile to maintain a great aesthetic result. This is a really interesting thing. We had a very unique engineer about 8 years ago, before a lot of computers could do this for us, showed his client a rendering on what a different technology would be and what their profile would look like. Well, little do you know that this is a lakefront property, and they would have to climb over a mound to get to their sailboat on their lake. So the homeowner said, no way, get me something else. So they build a Perc-Rite system, and here is the grass growing in. You can notice that the staircase and the deck and everything and the profile has remained the same. So quite a nice result. Flexible layout options. In this particular example, you can see there's like a well radius that they're trying to maintain. There are trees and different things on the other side of the property. So we go very narrow, we go wide, and it's just quite a unique situation. So this is it from plan view, and here it is built. So you can see how it quite fit in just nicely. Oh, I'm going to pause here. So a couple of questions just came through. Great questions. Is a deed notice required before a certificate of compliance is issued? Yes, so we do require a deed notice, and as part of the compliance documents, it is on the onus of the design engineer and the contractor to be in compliance. We have all of those documents available as like a template. So we took the actual deed notice, put all of our models in there to make it very simple for compliance. So yes, that is required. Do the filters ever need to be replaced? The answer is no. They are automatically backflush through those valves, and they are quite durable. They're like compressed disc filters, so they are quite durable and last for the life of the system. And the filters, more questions. Okay, so the hydraulic unit, as you saw in the pictures, is sitting on top of a tank that provides some warmth for the unit. There's also a heater strip that goes in the unit that's wired to the control panel that keeps it warm throughout the winter months if a company were to go away, if a homeowner were to go away, the heater strip would help keep everything warm. The emitters also work through the winter, as we mentioned, because of the nature of the pressure of the effluent coming out and the temperature. So, good questions all around. Here's another unique example of a project. So the only way to get the requisite amount of area in this backyard was to have a right angle following the property line offset. So this, we've seen this quite often, and it works very well. So very unique shapes. This is a really great example. There's a lot going on here that meets the eye. So you have a body of water, and you can see like kind of the dock here. You have a well offset, you have a property line offset, you have a tree, you're close to a dwelling. So not a lot of room to work with. So you have a very unique shape, and here it is built out. And you can see the body of water, the diagonal plane on the line, and a very unique shape. So we can really make it work. So any unique aspects you have for your property, please pass along, and we will be happy to help you get a custom layout designed. So lack of overdig. Here's another example where you have a drip dispersal field right next to a body of water, so you have to maintain your setback, but also there's a beautiful deck that overlooks that body of water. So if we had a 5-foot overdig here, they would have to rebuild the deck. So that maintained the use of the property very nicely. Here, the 5-foot overdig would have forced the homeowner to remove a gorgeous specimen tree. So we maintain the vegetation because of that aspect of our approval. Overcoming site conditions, and I apologize to those who have seen the presentation before. This picture has become quite commonplace for Oakson over the last 15 years. But out in Western Mass, this particular site, there's a pond or a lake literally like 20 feet off of the last support for the deck, and there was no other room. There was another camp to the left, another camp to the right. The only way they could avoid a tight tank was to do this, and I can report to this day that this system has been on the ground for 11 years and still working wonderfully. It was quite a unique example and something that we've shared a lot, but continue to do so because it could be one of our most unique examples. Sometimes there's the need to have utility poles in people's yards, so you don't need to call National Grid to move the utility pole. We can just work around it. And Dan, without saying names, do you wanna share, perhaps the uniqueness of the homeowner of this property?
Well, this is the house of a former commissioner of DEP who researched all of the disposal solutions and instructed his engineer to use Perc-Rite Drip Dispersal.
There you go. So here's another unique example of just an odd shape with a lot of slope, a lot of trees, and it's just, just not something that would really be conducive to another disposal options unless you wanted to, build that proverbial, kitty litter box in your side yard. So here it is, all different lengths of tubing following different shapes and whatnot. And again, so plowed or trenched installations, this is very unique to Perc-Rite Drip Dispersal, so thought we'd look at it again. So here you can see the ditch witch pulling in the tubing, and we have flags to represent where the next run needs to go. This was a great example of a Metro West homeowner who spent an awful lot of money on a beautiful, you know, home from the 1800s, and they just enjoyed the meadow nature of the property, and they said, no way do I want to get rid of the trees or clear the natural vegetation. There's got to be another solution. So in this case, they opted for Perc-Rite, and this is a system I think was built in 2006 or 2007. So it was one of the really early examples of Perc-Rite in Massachusetts. They're pulling a piece of tubing amongst that cluster of trees, and then they're going to go all the way to the left of the screen, almost off the page, for the next piece of tubing. But it really maintained quite the aesthetic value of the property, and these homeowners couldn't be more ecstatic with the result. So here you have a beautiful waterfront property. You know, imagine a big mound right, you know, along the view. So instead of that, use a vibratory plow, pull it into existing grade, and have a wonderful result. This is another picture example from that previous site. Just wanted to show you kind of the uniqueness of some of these trenches, you know, going around a rock, you know, going between two very young trees, preserving some of the roots. Just a real unique example that we like to show. In this one, this is an island installation. That it's actually up in Maine, but we thought it was a good example. There was no way to get equipment over there, so they had to hand dig everything. So you know, when you have unique island examples, and we have quite a few islands, not as many in Massachusetts, unless you know you're dealing with the big islands, you know, Nantucket and Martha's Vineyard. But off the coast of Maine, there are quite a bunch of islands that have residents on them, and then also Winnipesaukee and other lake islands in Maine or New Hampshire, that we tend to see a lot of these installations where you can't really get equipment over there. So you got to do it by hand, and Perc-Rite is quite a viable option. Preventing hydraulic failure. So Perc-Rite only discharges the design flow. Want a little bit more talking here and less slides, but we are a time-dosed system. So we can control the amount of flow that goes to the Perc-Rite system over the course of the day based on how many minutes we're going to program the pump to run. So if you have a 3-bedroom house design, we are going to program the panel to run enough minutes over 24 hours to only discharge 330 gallons per day. Now, this is a great thing to prevent against hydraulic failure, but it's also a very bad thing if you've installed the tank with a bad seam, or if it's a collection system that hasn't been, you know, properly sealed, or you have a leaky toilet. So what does that mean? So that means that you're getting extraneous and unintended water into the waste stream, whether it be through infiltration of rain or groundwater or snow melt, or internal plumbing that's not doing its job. So if that's the case, if you have a leaky toilet, there is a very good chance that if you install a Perc-Rite Drip Dispersal system, you may get an alarm during the first week of your operation. And I'm getting amens here on the my internal chat box from some of the operators that are on the session. So is that a good thing or is that a bad thing? Well, personally, we at Oakson think that's a good thing, because you know, one of the main causes of system failure out in the Title V inspector world is hydraulic failure. And because Perc-Rite has mechanisms built in to mitigate those things, we consider it a good thing. And it really is the flow meter, right? We talked about the flow meter that allows us to track the amount of flow, both from a gallon per minute perspective, but also from a totalizing perspective. So the operators, every visit, annual visit, can calculate the total flow on an average daily basis between the visits. We've had instances where we've had, you know, a retired couple, right, who have been averaging 320 gallons per day on a 3-bedroom system, but at every Thanksgiving or Christmas Eve, their alarm goes off when their kids come. Well, guess what? You know, we found that they had a guest bathroom somewhere, a part of the house they don't use anymore, with a leaky toilet. Because their water usage was so infrequent during the day, that leaky toilet was masked because it didn't quite tip the alarm. But whenever they had guests come on the holidays, it would go off. Well, a very astute operation and maintenance person said, geez, you know, it doesn't seem quite right. You're averaging less than your daily design flow, but you're 2 retired people, you're out a lot, you vacation, whatnot. That's not right. Maybe you want to have your plumber do an ink test in some of your toilets. And lo and behold, that's what they found. And that is a way that Perc-Rite can mitigate against that. In the time dosing aspect of it, you know, we have floats in the tank that run timers that allow the effluent to discharge over 24 hours a day and not be demand-based. So it really allows the soil for recovery, but also because of spreading out the doses, when you have a leaky fixture infiltration, that water can fly through all those float settings and cause the alarm to go off on a perfectly functioning system. But yet again, we're gonna, the operation and maintenance provider will help determine what the cause of that alarm is, and then we'll figure out if it's a leaky riser or a leaky toilet or whatnot. So we're getting near the end of the presentation, and we're doing very well with timing. So again, if you have questions, please chime in. So this slide, what I'm going to show is going to sort of we stole this from George Hoyfelder, so you know, I'll give full credit. So George has demonstrated over his studies that the soil layers up through the first 12 or so inches provide the most microbial activity for removal of not only bacteria, fecal coliform, but contaminants of emerging concern, so personal care products and whatnot, he's done studies on. But we've also learned that that active soil structure is doing a lot more for us than we imagined. So in the last 18 months, we have been running barrel studies at the Barnstable County Test Center that George Hoyfelder is still running. And these barrel studies are very unique. We are collecting effluent at 12 inches below pipe and 24 inches below pipe. But we're doing this in different types of soil classifications. We are doing it in loamy sands, sandy loams, pure Title V sand. So we are trying to replicate Class 1, Class 2, and Class 3 environments of soil. We have data, and I'm not going to share it with you today because we still have a couple months to go, but George is looking at nitrogen, phosphorus, fecal, and BOD TSS. And the reason why we started this study is because 3 or 4 years ago, up in Vermont, we were working on a large pilot testing for phosphorus removal for a ski resort that wanted to build an 80,000 gallon per day system. The state has very stringent phosphorus restrictions, and they needed to show basically non-detect. So we did a pilot Perc-Rite system, and in the end, it was non-detect. So it said, geez, you know, if this is doing great with phosphorus, perhaps it's doing other great things as well. So we started with George, and the results are quite eye-opening, and keep a lookout for papers and whatnot that we'll be publishing later on that show the results of these studies. George is going to continue on with these barrel studies and specifically study virus removal through shallow time dosed dispersal. So I don't want to, you know, basically, you know, Perc-Rite Drip Dispersal using our system, but virus study is going to be a huge thing for the future, as we all have endured the last year and a half as an issue. And just a quick note, this study is pure septic tank effluent, 100%, no treatment. It was actually piped in from live system, very consistent, like 200 BOD TSS levels, just pure primary effluent. So we're going to go on a closing now. I want to show you a couple of featured projects. One of them is in Western Massachusetts. It was a groundwater discharge permit project. They were looking for 25,000 gallons per day. They had very poor soils, but because of the loading rates that we have under the groundwater discharge permit program, Perc-Rite could be loaded at 0.75 gallon per day per square foot, and any other technology, including trenches or whatnot, had to be loaded at 0.2 gallons per day per square foot. So we only, the project only needed 33,500 square feet of disposal area, whereas anything else needed 125,000 square feet of area. So it was quite the thing for the site. And because it was a wooded site, it mitigated the need to do a lot of clear cutting. And the reason why we had to clear cut it all is not because, you know, working around the trees wasn't an option, because the adjusted groundwater mound required the system to be out of the ground no matter what, but it definitely mitigated the need to clear a lot more of the forest. And because this is a campground, it was very important for the project to maintain that, you know, campy feel. So here's the site plan. Here's the very unique custom details, whatnot. And these are the manifolds built. And it's a sloping site, so it's a top feed manifold. And you can see kind of the scale of what was done here. The three-phase pumps being built with the cool guides in the background. The pump station being built, and a very custom hydraulic unit inside the building. So quite a nice project. So our special thanks to the great folks out in Western Massachusetts who are involved in the design, build, and operation of this project. So lastly, I mentioned in one of my earlier slides that the very first project that Oakson was involved with was in 2006 in I think Weston. But I got a strange phone call in the beginning of the pandemic from a homeowner saying, yeah, I need a little help with my project. And they gave me the address in, it was Charlestown, Rhode Island. And I said, geez, I don't think you have a Perc-Rite system. And they said, oh, yes, we do. I'm like, no, you don't, because, I've been involved with, every single system. And he said, well, I have some documents that I found that I can share with you, and I'm pretty sure it's a Perc-Rite. So Charlestown, Rhode Island is kind of close to the Connecticut border on the Long Island Sound, and it's somewhat close to the University of Rhode Island, and they have a center for a demonstration site for technologies. So we learned that back in 1998, the University of Rhode Island, and I think it was George Loomis more specifically, worked with American Manufacturing to procure a Perc-Rite system to use at a house that they could have as part of their demonstrations. So the homeowner took some pictures of these plans and sent them to me. And lo and behold, I'm looking at, hand-drawn pictures of a Perc-Rite Drip Dispersal system designed in 1998 with the assistance of American manufacturing. Well, I kind of was dumbfounded. It's like, wow, yes, it was before Oakson, but I am like extremely interested in this because this has been in the ground for over 20 years. It seems like it hasn't been on the radar, so it hasn't been maintained. It's been used, but now the guy's getting an alarm. So, I got to check this out. So I went down there and had a mask on, and the owner was in the house, and I looked inside the hydraulic unit, and what happened was critters started nesting in the hydraulic unit, and they ate through a couple of wires and a couple of hydraulic lines, causing the system to not get out to the zones. And because of that, there was some spraying of effluent inside the hydraulic unit, and it caused one of the solenoids to fail. And then so the system wasn't working. So now, our common practices, and you'll see this on our details, is we call for stone to be put around the base of the hydraulic unit in the box, because critters can't really burrow through good compacted 3/4 stone, so it preserves the that aspect of it. But nonetheless, here we are. So I went out there and I was able to replace a couple of solenoids and remove some of the nesting, and we had a 22-year-old Perc-Rite system that was for the most part neglected and unknown to anybody other than the person. It changed hands like 3 times in the URI center, didn't use it anymore. It kind of fell off their radar as well. So I guess the moral of the story is the homeowner went on our website, and I think we have 3 reviews, so we're not too many, but the homeowner went on there and said, hey, I have a system since 1998, and I can tell you that the Perc-Rite system, it works. And we're proud to say that the components are very durable. And although we do promote and mandate operation and maintenance, as we all know in this industry, that sometimes things fall through the cracks, whether it be homeowner transition or transition through local boards of health. But the good news is that the Perc-Rite system is designed for sustainability, and here is a great example. So any questions before we conclude? So on behalf of Oakson, and I want to thank you for taking your time today. You'll be receiving an email with your as proof of attendance, and you'll be getting your 2 technical contact hours. And again, so Dan, you want to say goodbye or sign off to everyone?
Yeah, just thanks for your time this morning, and we'd love to help you with any further questions that you have. Feel free to give a ring.
And again, we've recorded this and we'll be posting it. So if you had any technical difficulties or want to review it again, this will be available to you. And keep an eye out if you are interested in larger flow design and implementation. We'll be having a presentation for that in about a month. So have a great day. Stay safe, everyone. And thank you for attending the Perc-Rite Drip Dispersal presentation.